Hi, welcome back for another 6 Caillou challenge. We've got the supermarket queue. There is a queue for the self-checkout tills at the supermarket. Your task is to write a function to calculate the total time required for all the customers to check out. Input, you have this customers array of integers, and each integer represents a customer, and more specifically, the amount of time they require to check out. So if it says 2, you could think of it like they take 2 minutes to check out. N, the second parameter, is a positive integer, and that represents the number of checkout tills. So let's just already improve this. Num tills, there we go. That wasn't hard to name it well. And then output, the function should return an integer, along more specifically, which is the total time required to process all customers. Now remember, you could have many tills running at the same time, so they can be processed at the same time. You're not just adding up all the times. Important, please look at the examples. Yeah, we'll do that. Queue time 1, so this was a trivial case. Imagine you get 5, 3, and 4. You got 3 customers there with their times. There's only 1 till, so clearly you just add them all up, right? There's no way to speed that process up. They all have to go through the 1 till, and you can simply add them up. Queue time 2 should return, you have 2 tills for this example. It should return 10, and you'll notice, imagine this 10-minute customer goes to till 1, 2-minute customer goes to till 2, they run their 2 minutes, they load up 3 on till 2, remember till 1's still processing, right? It would have 8 minutes left. You run 3 minutes here, this one's down to 5 minutes, and then you can put the fourth customer on till 2. They'll finish. So on till 2 you had 3 plus 3 is 6 plus 2 is 8 minutes, right? And then 10 minutes for the first customer. So the soonest that you get all customers processed is in fact 10. And then they give you another example of 2, 3, 10, and how that returns 12, because imagine till 1 you get the 2-minute person, till 2 you start with the 3-minute person. 2 will finish first, then pick up the 10-minute customer. 2 plus 10 is 12, and that's bigger than the 3 here that till 2 process. So final result's 12. I hope that's clear. Clarifications: there is only one queue serving many tills, and the order of the queue never changes. The front person in the queue proceeds to a till as soon as it becomes free. You should assume that all the test input will be valid as specified above. And then, yeah, we don't need the rest of that. They give an example of like a thread pool. If you really want to read it, go ahead. You don't need to do that to understand this challenge and do it. So go ahead and pause this, have a go, come on back when you're ready. For my solution, I decided to use the queue data structure since it's mentioned a lot here. What I'm about to show is not the most efficient solution, but what I wanted to do was to use the queue because we haven't used it a lot in the series, and also to model this situation of a supermarket and software. So I'm going to actually create a class to this end. I'm going to call it a till, and I'm going to have these till objects then, and I can sort of run them at the same time and use that to get the result. This won't be efficient, but it's more important to me to teach you how to model things, real life scenarios in software. That's what this video is more focused on. You've probably noticed that oftentimes my solutions aren't the most optimal, but the point of this series is to teach software, so software design. So let's do that. Okay. First things first though, before we even do any kind of real work, let's handle a few of the really trivial cases where we can just get out of Dodge if those things aren't right. So imagine you had no customers, right? Just return 0, right? It doesn't take any time to process 0 customers. Okay, so that's one potential pitfall. Another we could look at is, we saw in their examples, if num tills equals 1, right? Clearly then we're going to return customers.sum. You just add up all the times, right? There's only one till. There's no way to speed anybody up. And of course, I'll bring in system link for that sum implementation. Good. And then one third simple case that I wanted to discuss. Let's say that the number of customers is less than the number of tills. So imagine you had 4 customers and you had 5 tills or registers, as we often say here in America. Then you would just take the max value of the customer times, right? So if customers.length, nobody's going to have to wait, right? They can all immediately go to a register, and then the total time is just the time of the longest person. So if that's less than number of tills, we can say return customers max. We'll use that link method as well for enumerable collections. Good. So I just covered a few simple cases here where we can just get in, get out. We have our answer immediately. Now let's handle the general case where you have customers and limited access to resources, and so we'll make that happen. Now I said I was going to use a queue to implement some of this. I'll just call it queue, new queue of int. We'll initialize that. Now that's ready to use. And so what I'll do is I'll just make a loop to load up this queue. Int time in customers, right? Those values represent customer processing times. Queue and queue time, right? And this will just load up my queue. And go ahead and pull up the queue page so you have access to its methods here. You'll notice there's a dequeue, which is the opposite of enqueue. That will load up. This one will take an object out. Queues are what are called FIFO structures. That's an acronym for first in, first out. So whatever you enqueue first comes out first. That's kind of the opposite idea of a stack, which is a LIFO, last in, first out. So yeah, that might be handy for you to keep this page open. So we have that. We have our queue loaded up with all the times. That's good. And now I'm going to make some of these till objects that I was talking about. I'll make an array of them. These will be our tills. Equals new till array num tills. We'll have that many tills running. And we'll implement this class to make that work. And maybe, yeah, let's do that now. So we'll make the till class. We're going to need a constructor, public till, and it'll take a customer time as input. That'll be sort of the starting point for it. Now, what kind of properties do we want our till to have? Well, I'm going to have a property called isOpen, and this will tell me if the till can accept a new customer or not. And so I'll say isOpen. Before I implement this, let's add the rest of the properties. So I wanted something to keep a running count of the times spent by each customer at the till. And the idea is that when that's all done, I can simply go through my array of tills, find the max value, and that should be the answer to the question, right? So we'll call it public int, or I suppose I need to return a long, right? And maybe this value can get really big. I don't know what the test cases are going to hit us with. Let's call it total time, and I'll just make it anybody can get it. I want my setter to be private. Nobody outside the till can change that total time. That makes sense. And then I'm going to make a private integer variable that I'm going to call time. And the idea with this is going to be that I'm gonna sort of, when I make a till, let's say it has a value like 2 here. I'm gonna have a collection of them, and then I'm gonna sort of call an update to sort of step these values down by 1 each time. And when they go to 0, I'll know a till is. I can set this is open flag to true, and then I'll know I can load a new customer in for this particular instance of a till. So yeah, I'm definitely going to want a means of public void, how about add customer, right? And it should take a time. And then we could do some simple checking here. If time less than or equal to 0, that wouldn't make much sense, right? Throw new exception, whatever you want to write here. Put invalid time. Shouldn't come up. And then finally, I'll set the private member time to the time passed in. And then also, let's update our running count of times. Good. So that should work. And the other thing that I hinted at is that we'll have this public void update where you can update a till. And for this method, this is going to be incredibly simple. I'm just going to say return, or actually just decrement our private time field by 1, right? So on each update, 2 will go down to 1, the 1 will go down to 0, and then is open will get set, and let's make sure that happens, right? So, and notice I'm just going to switch things up a little bit. Instead of writing the full body, we've got this expression body operator kind of thing. It's just like what we use with the lambdas. I just wanted to show you. I've seen it come up a lot in the solutions on here, and was hoping it wasn't confusing anybody, but if you want to read about it, there's an article here, expression bodied members, and you can scroll through and look at some of these, right? It's just saying like, hey, whatever's coming next is like the body of your function. So you don't have to use the curly braces that we normally do, like here and here. That's all. Okay, so that's good. And then we have to implement is open, right? So now that we have these fields, we can say that for is open, I could say for its getter, I could just say time equals to 0, right? Isn't that what that means? Once the time rolls down to 0, it's like the flag goes up, hey, I'm open. And as soon as someone adds a customer after that, it sets time. Time gets set to some non-zero value greater than 0. Excuse me. And then you can imagine if anyone pulled this is open after that new customer was added, time would not be equal to 0, so it would return false. So I think that'll work how we want it to. Again, I just used that little operator here, but if you didn't like that, you could, do something like return time equals 0 if you wanted to do it that way instead. Just, tomato, tomato. I thought I'd switch it up this time. Okay, so let's see. Let's go work with our new till class then. Oh, one thing, the constructor we left out. So you can imagine, since I have this add customer, it'll work the same way as when I'm initializing a customer, just like when a till opens up and you're adding another one. Same kind of thing, so I'll just leverage, instead of copying all the body of this into the constructor, I'll just say, hey, just use that method itself with customer time. Casing matters. Okay, so now I think this till class is implemented. So good. Our queue's loaded up, ready to rock with the times. we now have a collection of tills. We have an idea how they work in the number that we were provided. That's good. And so now we can get on with processing these. So first things first, let's work with the queue to initialize the tills. Load up the initial customers at each till, right? So to do that, I could say for to I equals 0, I is less than the number of tills, right? And plus I. And what we'll do here is just sort of set up those initial queues. So let's go if queue count is greater than 0. It really should be. I probably don't need that check here. Tills I equals new till, right? And we have to give it a customer time. So let's just pull that value right off the queue. Remember we looked at DQ. If you want to see it just returns the object that is removed from the beginning of the queue. So it's an integer in our case. So yeah, you can imagine we had 10 customers and 3 queues. This bit here just means, hey, we've got 3 tills, we're about to get started. You might as well take the first 3 customers and get them assigned. And so that's all this does is we had empty tills right from this statement. We just allocated the memory for however many we needed, and this is actually putting the meaningful till objects in these array locations. I hope that's clear. Good. So now we're ready to rock. The main body, right? So while we have this queue, we could say while queue count is greater than 0. That means there's customers in line. When there aren't customers in line, we are done. So what to do? Well, we're going to go through our collection of tills and sort of watch them to see when tills open up, and we're going to process customers and update them and get them out of there when their time is expired. So let's do for each till in tills, right? Okay, for each one. Now what I'm going to do to start is I'm going to say this till update. We know they're all loaded up to start, right? An update's just going to take their times. What do we have here? Like 5, 3, 4, and it's just going to decrement them all. That's what I'm doing every turn. You can think of this as like a cycle, right? And so each time I'm on a timer, I'm stepping down by 1 minute each time. That's going to go to 4, 2, 3, and then 3, 1, 2, etc. Someone's going to drop to 0, and we're going to say, hey, all right, we got another till, load the next one up. And so to do that, we will check if till is open, right? We're going to use that property to determine that. And then we can say, we got to make sure there's elements available, right? So anytime I'm going to DQ, I like to just make that safety check there. Till add customer, right? And we'll say queue, grab the next one off the queue. We had a till open up, trying to make this very readable. If there are customers still in line, right? This is just computer talk for what I just said in English. If there are customers still in line and a till is open, then it's time to add a customer, and you should get its time value from the queue. Easy, right? Pretty readable. And so you can imagine this loop will continue while we have customers in line. It'll come back to the top. It'll run the update. Maybe it takes a minute off everybody and nobody's open yet. That's fine. Then you keep looping until and then somebody, or maybe multiple, will register as open. And then whenever that happens and customers remain, keep trying to assign them to a till. And the idea being, again, that once we have processed all of the customers, it's simply a matter of returning tills We want the max value, right? The max value, but what does that mean? We're using a custom object, right? When we used max with integers, it was easy. The behavior was sort of built in. It would just take the largest integer. But we made a custom object here, so it doesn't know by default how to do that. So we're going to tell it how to do that. Well, we're going to add our lambda in here, right? I just called my parameter till. I think it's a good name for something that's in tills. And then I'll say till our total time field, right? So I'm just telling it, like, this is the property that we're using to get the max. So good. I think that should do what we want it to do. Let's run it and see what I messed up. I think we're gonna need collections for Q, right? System collections generic, right? Let's bring that in. Using system collections generic. Okay, let's see what we get. Okay, error, the type or namespace exception. Yeah, so when we threw that exception for a time value less than or equal to 0, which means we should bring in using system. If you don't believe me, you can look up exception class and it should be in the system namespace. Good, so we hit green. I'm gonna hit the attempt. And we're clear. So I'm just gonna make sure you understand this. I'm gonna talk you through it one more time. We handled the trivial cases first, right? And certainly, before I get into it, you could refactor this too if you wanted to make methods that would load the queue, or give you a queue based on a list of customers, right? And just return that and kind of condense this. And same thing, initialize tills, right? And you could kind of condense this code if you want. I'm going to leave it like this. It's still, I think, pretty small. So anyways, we did our trivial cases, right? We weren't going to go to the trouble of queuing up times and stuff if times don't even exist. So, and yeah, why burn processing time if you don't need to handle these simple trivial cases? So then finally we get through, right? We've got the general case. Let's make a queue and let's load it up with these times in a first in, first out manner. Those are the rules at the line in the supermarket. You can't cut, right? Just like the bank or somewhere else. And then we made this helper class till, right? And to do that, we gave it these properties, right? It had this nice flag that could tell us when it's open. It tracked its total customer processing time. It had a mechanism for adding new customers. And we sort of use this update method as like a almost like a game loop, you know, or in game development where you're kind of processing stuff each frame. It was just a made-up system to walk time down. And then we had this private time field that would maintain that state, and once it got down to 0, we would know that the till was open. So yeah, it was just a way to start getting comfortable making custom classes and using them. After that, it was pretty simple, right? Like we declared memory here, we allocated space for our tills, and then we set them up with actual till objects here with the first however many num tills customers. We loaded those up with their first customers. And then the while loop sort of gets into, okay, after the registers are initially assigned, kind of wait and update until one opens up. When it does open up, see if there's another customer. If there is, assign that new customer to the till that popped as open, and just keep repeating until there's no customers. And finally, once you do that, you can just look at your tills. Since we gave it this handy total time property, we can just look through those, find the max one of those, and return it. So I hope that was clear. I think I'll submit my answer like this, but yeah, you could definitely refactor to get that down if you'd like. I'll go ahead and submit, and yeah, look through the other answers, see what you can get. See, nice and short and sweet, all sorts of good answers in there. So yeah, you know where to find me if you have questions. Otherwise, we'll keep rolling. Thanks for watching.